Okay, thank you for attending. My name's Nick Zezovski. I'm the Kingray product manager. I've been with Kingray 2015, so what's that, like 6-7 years now. Started off as a BDM. In the last few years moved across into product management. Prior to that I was with Hills Antennas for over 10 years. So I've been in the industry for about 20 odd years now. Okay, so essentially going to talk about Masthead amplifiers, why you'd use a Masthead amplifier, and what type of amplifier should be used. So to start with, I'm just going to go over some of the basics in regards to signal levels, what signal levels that we actually sort of want. So the first line refers to the signal level from an Australian standard perspective. So the standards say it needs to be a minimum of 45 dB at the wall plate and a maximum of 80 dB. And within the notes they say ideally 54 dB. Now the reason for that particular range is because the tuners within TVs, right, are typically designed to work in that range. So the TV tuner will work down to at least 45 dB of signal level and up to around 80 dB. Not all digital tuners are the same, just like not all TVs are the same. So some tuners within TVs will actually are better quality. I've personally come across some TVs that will, where I've seen like 35 dB, so well below the Australian standard, and it's perfect, no pixelation. And believe me, I was quite shocked when I saw that because that's not common, okay? But in saying that, should always stick to what the standards are, because you never know what's going to happen with that particular TV set. So, from an installer's perspective, if you do a job and you've got under 40 dB and you tune it in, you go, oh great, there's no pixelation, perfect, I can leave, okay? But if the customer decides to pull that TV out, or if it fails and they put in another TV, well, you don't know how good that tuner is, and that might, once they put that one in, they could get a bit of pixelation then, okay? Because I said they're not all the same. So from an installer's perspective, that's really what they need to aim for. And also MER, so modulation error ratio, refers to the actual quality of the signal itself. So on the meter, it'll show the power level and the MER. So as long as the installer's got more than 25 dB, then they should be fine, and ideally above 28. Now the reason why those figures are in there, where I say ideally 54 and ideally 28, the reason for that is, as an installer, when you check something, that doesn't mean that it's going to be the same level an hour later or a day later, because TV signals are very much affected by the environment. So if it's sunny, if it's cloudy, foggy, rain, all that sort of stuff, that affects the signal level. It's not going to be exactly the same level coming in at the antenna all the time. Therefore, you don't want to, from an installer's perspective, you shouldn't be leaving an installation at the minimum level for both power and MER, okay? And that's why they have the ideal, because that's like gives you a bit of headroom. So if there is a bit of change in that signal level, even if it drops a couple of dB on the MER or a few dB on the power level, it's not going to affect the signal. That TV is still going to be locked in and there won't be any pixelation. So keeping that in mind, then we go into mastheads. Mastheads are designed typically to have a minimum 40 dB going in and maximum 80 dB. And again, I'll go into the specifics of that a little bit later. And some of the other things that I'm going to go through, but we need to keep in mind, is cable loss in a system and how much loss we have of signal through passive devices like splitters, okay? So this is an image from, it's actually a government website called MySwitch. So on that particular website, you can actually put in a suburb or a particular address, okay? And then it will tell you which is the best transmitter to be pointing to. So, and that website can be used for pretty much anywhere within Australia. So whether it's a capital city area or a regional area. So if it's an area that you're not familiar with and someone says, oh, I need an antenna for this area, 50 Ks out of the city or whatever, or 100, and you're not familiar what transmitters are around or what they should be using, it's a website you can go to, put in the suburb, or if you want to go more specific, you can actually put in their address, and it will tell you which is the best transmitter for that area. But what I've done here is I've dropped the image for the Mount Dandenong transmitter, which is the main transmitter. Okay. Now, this particular transmitter covers the majority of the metropolitan area. So you can see everywhere that's green is good signal area. So even all the way down to Geelong, you can pick up, Geelong to here, as the crow flies, is probably about 100 Ks. So even down in Geelong, you can pick up from the main transmitter. Now, as the signal gets weaker, you'll see where it's a lighter green, and then the orange is sort of like, it's iffy. You might get good signal, you might not. And certainly where it's orange, you're pretty much 99% guaranteed that's where you have to put a masthead in as a minimum. So even if it's just a single cable, chances are there's only maybe about a minimum signal level, to come into that amplifier. So in that instance, yes, you're definitely going to use a masthead. Now, with the Mount Dandenong transmitter, it is predominantly VHF, and there is one channel which is UHF, which is that community channel. Okay, so you find that a lot of antennas being used to pick up from this transmitter is a combination antenna. So it's a VHF and a UHF. But in saying that, the community channel is also available through streaming. So not everyone necessarily is concerned whether they do get the community channel or not. And where they're not that fast, then they'll just use a VHF antenna. So like that one there, which is just channel 6 to 12. Okay. The signal coming off the transmitter is horizontal, which means coming off the transmitter, it's coming in this direction, so a horizontal plane. And I'll go into that a little bit later with the antenna. Well, actually, let me bring that up now. So the antenna needs to be in the same position, okay? So if its transmitter is transmitting horizontal, the antenna needs to be like that, just the way that antenna would be, as you see there, right? There are some transmitters where the signal is being sent in a vertical polarization, so it's like this, traveling this way, which means the antenna needs to be matching. So if the antenna isn't matching and it's like that, automatically you're losing 20 dB because it's not in the same polarity. So it needs to be matching. So amplifiers. So to cover a antenna or a wideband application where it's VHF and UHF, you need to use a wideband masthead amplifier. So if you look at the part numbers, MH basically refers to masthead, W is wideband, which means it's both VHF and UHF. The number behind it is the maximum gain level. So you'll see that with the maximum gain level on the 25s, that's only referring to the VHF part, which is 25. Okay, the UHF. The VHF is always a lower gain level. Same with the 35. Maximum is on the UHF side, and the VHF is a little bit lower. Okay, and the reason for that is if you've got UHF and VHF coming off the same transmitter, you'll tend to find that the further that signal goes, okay, UHF dissipates a lot quicker. So let's say you're like 50 Ks away, that antenna, or even if you're using a separate UHF, VHF antenna, you find that the VHF signal is higher than the UHF signal. So you don't need to amplify the VHF as much as the UHF, okay? And you want to try and keep it a balanced sort of signal level as well. So if UHF is coming in 10 dB lower than VHF, okay, you want to adjust the gain so you've got more UHF and less VHF. Okay, so coming out of the amplifier, both signals, both VHF, UHF signals are relatively even. Okay. With the amplifiers, there's a gain pot, so the blue pots that you see here. So Have a look at that one there. So you can adjust the signal for both VHF and UHF. And it's a combination antenna. So the input on the left-hand side is for VHF and UHF. You can, it's got two inputs, so you can separate it if it's two separate antennas. So one would be the VHF input, one would be the UHF input. Okay, but if it's a combination antenna, so it's the input on the left, which would do both. Talked about the gain. Obviously you need a power supply, so I'll talk about power supplies a little bit later as well. And then this is the output figure. So you know how I said before, I think I might have said, input into a Masthead is usually up to around 80 dB max. And the reason for that is if you've got more than 80 dB and you're amplifying, you know, that signal. So let's say you got 80 dB of UHF and you're amplifying it to the maximum, which is 35, then you're at 115. So you're over the maximum output limit. So it's a bit like an AV sort of amplifier. You know, you don't want to overdrive that audio signal, so to speak, because if you do, you're going to get a distortion, okay? And that affects the signal. Same with Masthead amplifiers, okay? So from an installer's perspective, they need to make sure the signal level isn't too high. And if it is high, and they do need an amplifier, so you think, well, if the signal's high, why do I need an amplifier? Well, it could be a large system. So there might be multiple splitters, a lot of signal, a lot of like long cable runs, so they need to get a lot of signal in. That's why they'll still use a Masthead even with high signal, but they need to make sure that they don't go over the output figure. Okay. So in both instances, it's 108. So yeah, essentially the difference between the two is the maximum gain. All right, any questions? No? Great, okay. Now, if they were to just go VHF, so just use a VHF antenna, then ideally you just want to use a VHF amplifier. Because yes, you can use one of these and just have it as use it as a VHF only, okay? But you're paying, you know, $10 more because of the extra UHF features that are not, well, they'll never be installed because it's just a VHF installation. So you're better off just using a VHF amplifier. And with this one, it's a 25 dB gain. So if you look at the first one on the wideband, the VHF is only a maximum of 15. Okay, so better off using a VHF only amplifier to match with the VHF antenna. Okay, you got more gain, and you can still adjust the signal level and bring it down 10 dB. Again, maximum output's 108. Now there's a couple of other transmitters around Melbourne other than that main one, okay, and they're UHF. Now we've got one here in the city, so and you'll see the pattern is very much around the CBD and just a couple of the outlying suburbs, okay, and then there's another one on Chapel Street in South Yarra, okay, and the reason they have these two particular transmitters is because of the shadowing effect from all the buildings, from, you know, we've got multiple 50-story apartments and that. So, you know, you could find that the signal was good and then all of a sudden a building goes up, which is directly in the path of where the signal is coming from, and that particular building, which is smaller and behind this big one now, is going to have really poor signal. So they can no longer get the signal from the Dandenong transmitter, which means they need to put in a small UHF one and redirect it to the transmitter at this location. Okay, so that's why they have a small UHF transmitter in the city and one just out at Chapel Street at South Yarra. And again, that's what they're designed for. They're small transmitters just to do localized area, just to overcome those issues. Now there's another one which is out at Selby, which is down past Seaford, I think. Again, so this particular one is just the Selby and a couple of the suburbs around. the government would have put it in because obviously it would have been a poor reception area where they couldn't pick up signal from the main transmitter at Mount Dandenong. So they put in a little one there. Now you'll see if I go back to these two here, the one on Burke Street and Chapel Street, they're vertical, which means the signal is coming, is sent from the transmitter in a vertical polarity, so this way, which means the UHF antenna can't be like this, it needs to be on its side to pick the signal up. Okay, so that's for the two in the city, but the one out at Selby is just in a sort of traditional horizontal installation.
So is there any reason why they do vertical opposed to, why don't they just keep it all uniform?
Yep.
Is it distance or is it?
No, because let's say for example, you've got this particular transmitter, and let's say it is horizontal, okay? Now, even though, you know, you've put in a UHF to pick up this one, that doesn't necessarily mean that you're not going to get the UHF channel from the Dandenong. So because that one's horizontal, so all of a sudden you could get two lots of signal coming through. And if that's on the same channel as well, it's going to add additional problems. Okay. In this instance, they're different channels. A bit of this is a carryover from the analog days when they wanted to make sure that there wasn't signal interference. There wasn't as, back then there were more channels from multiple transmitters, especially in the UHF frequency, that could interfere with one another. So that's why they put in, when they put in a little one and there's potential of interference, they'll put it in a different polarity, okay? And even if it's a different channel number, the problem is if it comes through, then, you know, when you do a scan or a rescan, you can have two lots of a particular channel. And the other issue is that sometimes that one might be coming through, but might not be as strong as this one. So that second unwanted channel that's coming through could cause some pixelation as well. So hence the other reason to have a different polarity. So that way, when it does come through, okay, chances are it'll still sneak through, but because of the different polarity, it decreases by 20 dB automatically. Okay, so UHF Masthead amplifiers. So essentially it replicates what I discussed with the wideband ones. So MH Masthead, U being referring to UHF only. Two models, or two main sort of models in the range, the 25 series and the 35 series. These have got two inputs, but it's a bit of a carryover from the analog era. So the second input here is actually VHF, but there's no gain. It's just like a pass-through feature, okay? But we're actually removing that. So these UHF ones moving forward are going to look like the VHF one, which is like this, where it'll just have a single input. So this is the VHF 25, and the UHF ones in time will look similar to that, where there will just be one input. Now, one thing I didn't mention is the shielding. So there's two models. So within the U's and within the W's, within the 25 and 35 series, there are shielded models. Again, it's more of a carryover from the analog era, where there was more signal interference around, more signals around the TV frequency range, especially with analog, you know, pager and all that other stuff, which could cause interference with the TV signal. I mean, 90% of our amplifiers nowadays are generally the unshielded one, because you just don't need this full shielding, okay? Again, you'll see the maximum output figure is 108 dB on these two, which is the same with the wide bands. Any questions? Okay. On to the next one. So this is just a couple of signal system scenarios. So the first one, we're looking at 60 dB coming in at the antenna, or should I say coming out of the antenna. And then as a typical sort of install, we've got a two-way splitter, we've got roughly 20 meters of cable, and we've got connectors in the system. So we've got 60 dB, we've got 4.5 dB loss for a two-way splitter. Cable loss is 2 dB every 10 meters, so 4 dB in this instance, a bit of loss for the connector, and then at the wall plate we're going to have 50 dB. Okay, so it's essentially, it's just mathematics. It's basically, you know, these numbers don't change. You know, so whether it's a two-way or if it's a four-way is more loss, but it's always going to be that same level. Same with the cable. So you say, you know, I've got 60 dB. This is my system. I've got this in this much cable. If I work out, I know what my level is at the wall plate, even before I go connect everything. Okay, once I know what the level is at the antenna, and I know what's in the system, I know what I should be getting at the wall plate. So in that scenario, you say, okay, well, I've got more than 50 dB. I'm, you know, 5 dB above the minimum. I should be fine. I don't need to put a masthead in. But if I've got 10 dB less at the coming out of the antenna, same system, I'm going to be under what I need to have at the wall plate. So at that point, you know straight away, I need a masthead. I don't need to connect everything, put it all together, and then check. You're still going to check to make sure you've cabled it up correctly, so it all matches. But with that scenario, you know straight away you need to put a masthead in. Sorry. So yeah, it's basically just mathematics. You know, once you know and understand what the signal level losses are, then you know what amplifier you need. Then it's a matter of saying, okay, it's a UHF install, I need a UHF, or it's a VHF, I need a VHF, or I need a combo, so I need the W. Power supplies, like with all sort of electronics, it needs power. So pretty simple. You're gonna have a power supply that'll look like this. So obviously this connects into your power point. The other end, you're going to have a power injector. Now the power injector, one end will say to the TV, the other say to the amplifier. So the bit that says to the amplifier is connected to the wall plate. The bit that says to TV, obviously you have a fly lead that'll go to the TV. And then what it does, it'll send 14 volt back up the coax cable to power up the masthead. Okay, so it's what we basically call remotely powering a masthead, because you're not going to have something connected directly to the masthead. All right, so typically, you know, amplifiers are remotely powered when it comes to mastheads. That's generally how it's done. And you've got a PSK 06 and 06F. The 6 and the 6F, the only difference is the connector type. So the F is the F type, and the 06 is the PAL male fitting. And then there's the 08 models, which are AC. But by far we sell more DCs, DC power supplies, being the 06 nowadays, versus the ACs. But both work with our masthead, so it doesn't matter which one is used. Okay, distribution amplifiers. Okay, so I don't have the covers off, but that's a DW32, which is the one at the top, and a DW42. So basically, once the cover's taken off, you'll see the board. Looks very similar to like the mastheads. And again, you're just going to have the gain pots to adjust UHF and VHF. So DW32's got two inputs, so you can use it as a separate VHF, UHF, or again as a combined signal coming in. And the DW42 is the same. You've got two inputs. You can adjust the VHF and UHF in regards to gain. So when it comes to gain control, you've got more adjustment on the 42 versus the 32. Again, where you would use a distribution amplifier is different to a typical sort of house install. Something like this is typically used within more of a commercial premises or apartment block, where from a house perspective, you need a power supply at a wall plate to remotely power up the masthead. In this scenario, you don't want to do that, because it means that if you have a power supply in, let's say, one apartment, okay, or one location, so like in a building like this, where you might have multiple TV points, for example, and you just have one power supply. If that power supply is switched off at that location, then obviously affects everyone, right? Same, if you have one power supply in one apartment and the customer turns that power supply off, or they move out of apartment, someone else comes in, they go, oh, that's mine, I'm going to grab it. It affects everyone within that building. So with distribution amplifiers, typically they're in a communication sort of box, or sort of like a centralized area where it's what they call like community power. So no one's paying directly to power up the masthead. You know, it'll come under strata, for example, within an apartment block. And it's in a location that is typically not easily accessible by any of the tenants. So if someone needs to do any servicing, it's in a comms cabinet or something like that. And that's when you'll have local power. So with these two, the power supply will be like this, but it'll have a DC socket. Okay, so typically where it's installed, there will be power in that location, and it's the power supply is directly connected to the distribution amplifiers. Again, DW's distribution wide is wideband, so it does both VHF, UHF, maximum 32 dB gain, maximum 40 on the 42. The other difference is, other than the gain control difference, is the maximum output level. So this one you can go have 118 dB output, so it's 10 dB higher than the mastheads. Okay, so they're really designed for that sort of commercial type application, not so much domestic. Hence, they have a higher output figure. Any questions on the distribution amps? No. Now, this is our big commercial distribution amplifier. The main difference between this one and most other amplifiers is that most amplifiers will do free-to-air only or satellite only. So all the ones I've showed you there are free-to-air amplifiers. Now, we do have a satellite amplifier in this type of housing, which does just satellite only. Okay, but this one here does both free-to-air and satellite. Okay, and it's what we call a super broadband amplifier, because it does both that free-to-air and satellite signal. So it's got a single input, so it's designed that where you'll have your free-to-air and your satellite coming in together, and it'll be connected to a diplexer, which is like a two-way splitter. So it'll have a free-to-air and a satellite input, and then one output. Okay, the output from that will go into the super broadband amplifier. This particular amplifier has more features than most amplifiers. So it's got input attenuation for both free-to-air and sat, which means that I can automatically drop my signal level by 10 dB coming in. I've got gain control over both free-to-air and satellite independently, and I've got equalization control, which means that if the slope of the satellite, for example, and it more so affects satellite than free-to-air, but if the slope of the satellite, so you're going to have satellites at much wider range, so we're talking about from 950 megahertz up to about 2.4 gig. So if I've got signal level at around that 1 gig range, and let's say it's about 80 dB, and then at the 2 gig range it's around 70 dB, so I've already got a 10 dB sort of difference. So that equalization allows me to bring up the signal at that higher end, okay, and have more of a flatter signal, okay, before I then distribute the signal out. So it allows an installer to have a more balance and more control over the signal overall. And because you've got independent control for the terrestrial and satellite, it also means that if I've got less free-to-air signal than satellite, then I can increase my free-to-air signal, or vice versa. So I've got more of a balanced signal coming out. Okay, and in saying that, when I referred to signal loss before, being 2 dB for free-to-air, in satellite it's about 3.5 dB. So you're going to have more signal loss because it's a higher frequency over the same distance. So when you're using an amplifier like this in that type of application, you would adjust the signal so you got more satellite versus free-to-air to accommodate that loss through the system. Okay, because as I said, satellite, there's more loss through coax cable and through passive devices like splitters. So you want to have a little bit more signal coming out on satellite versus free to air. Okay, so that's one of the great benefits of an amplifier like this, is a lot of control. And again, you'll see that the output figure is higher again. So 120 and 122. So it's really that sort of, very much that commercial application where it's an apartment block, and we've got free-to-air signal and satellite, which is typically Foxtel signal going through a building. Gain control is very similar with terrestrial and satellite, so 36 versus 40. And power supply is connected directly. The difference is, unlike the previous ones where it's like a DC socket like this, on this one it's an F connector. So you'd use a PSK 18M or a PSK 183F, which has got a F connector, so it actually screws in. Okay? And the benefit of having something like that, as opposed to something like this, is someone could accidentally knock this sort of power supply, or if they haven't quite put it in and it's clicked in nice and solid over time, it could come loose. Okay? Whereas with an F connector, once it's screwed on, well, there's no reason why it should come off. So that's the other benefit. Any questions? No? Great. Okay. We're almost at the end. So this is just the splitters. So as I mentioned before, with the two-way splitter, we got 4.5 dB loss at 1 gig. So everything with free-to-air is less than 1 gig. A 4-way is 8.5, and an 8 or a 6-way is 12 dB. So the bigger the splitter, the more loss. Okay. Same with satellite. So again, we're looking at higher frequencies and the loss is greater. So that's why I said when you're using that amplifier, you should design it and make sure that there's more satellite signal coming out than free to air, because you've got more loss not just in cable but also in passive devices such as splitters. Okay, and with all of these splitters, they're all power pass all ports, which means from, let's say, you're putting in a 4-way splitter at a house. When you're putting the power supply, it doesn't matter which connection or wall plate it is, it'll allow power to pass, okay, through all of the ports. Now there are some splitters on the market which are power pass 1 port, which means that particular power supply needs to be on that leg of the splitter. So if that power pass leg, let's say it's the first one, and that goes to bedroom 1, then the power pack must be at bedroom 1, okay? Because it's only going to allow power to pass through that port. If that power pack is placed anywhere else, okay, then it won't go through, okay? So that's one of the other benefits with using a power pass all port splitter. So it doesn't matter where that power pack is located, it's going to pass power. And if the customer decides at some point, you know what, I don't want the power pack here, because I want to use that, power point for something else, I can remove that and put it in, the second bedroom or the second living area, or it doesn't matter where they put it, it's still going to pass power. Okay, so that's one of the great benefits of using power pass splitters. Okay, any questions regarding splitters? Okay, great. That basically takes us to the end of the presentation. Do you have any questions on any other Kingray sort of products that you want me to have? Any questions? Go through.
So sorry, Nick, with the injectors.
Yep.
Does the DC offer less interference than AC injectors? So like in country Victoria, like one of the guys, because they say like electric fences and so forth. Is that true or?
Yes, you can get interference through electric fences.
So they prefer the DC piece or not?
The DC or the AC?
They prefer DC.
They prefer DC, yeah. It's one of those things where there might be a benefit of using AC over DC or DC over AC.
Yeah.
All our mastheads will work with either. The DCs are slightly, obviously, a different design to the ACs. But yeah, that could be one particular scenario where they would prefer to use an AC over a DC. Yeah. But yeah, so at the moment, we carry both styles in the range. We're going to continue. We're not dropping one. There are a couple of models within our range that are just DC only, but all the ones that I've gone through there will power up with either an AC or a DC power supply. Yeah. Okay. Thank you.